tell Atharv to please join again. So what did we do in the last lecture? I introduced you to a new concept, right?
Constructors.
Yes. So what is a constructor?
It's a method for instantiating the data members, and it has the same name as the class.
Okay.
It has no return type.
Okay. Same name. It's a method. Same name as the class. With no return type. Do you remember I had given one example as well, which tells you what are the different types of constructors which are available?
Yes, ma'am.
Yes, ma'am.
So what are the different types of constructors?
Default, non-parameterized, parameterized, and copy.
We discussed the types of constructors. So the types. So what is a default constructor? What is a default constructor?
Which is created by the compiler.
It is called by the compiler. It is whenever you create an object of a class which is not having constructor, like whatever programs we wrote so far, we did not write any constructor method, right? So whenever you create an object of that class, the compiler calls that function, the default constructor function on its own. Okay? So that is a default constructor. So no argument. What are the other three constructors you can create on your own? They are no argument constructor. Then parameterized and non-parameterized. Sorry, no argument is the non-parameterized. Then you have parameterized, and then you have the copy constructor. So no argument means no argument. The function is not having any arguments. Parameterized means it is having the arguments, and copy is a special type of a constructor where you are allowed to create an object's copy. Okay. So I gave you one example for this about you trying to buy a pen, right? The pen example. So in which you can understand these three concepts, right? Do you recollect, everyone?
Yes, ma'am.
Yeah. So let us just move on to the program. Okay. For this particular constructor example, let us take a simple class called the rectangle class. So I'll just create a class rectangle. What will be the data of this class and what will be the functions? So private let us define the data members, the length and the breadth. Right? Now we have to create these constructors. Whenever you're creating an object, let us create our own constructors. Let us say I want to create a constructor which is not having any argument. So how will the constructor look like? I told you it's a function. It's a special function which does not have a return type, right? So it will not have anything like void, int, float, double, whatever, char, whatever. It will not have that. Its name is the same as the class. The name of this function is the same as the class. And then you will specify the parameters, right? So if I have to create a constructor with no arguments, then this is how it will look like. I'm writing the signature of this function, right? Okay, we can define it outside. We'll define it outside. If my function is having these parameters, if I want to create, this is a non-parameterized or no argument constructor. Okay, if my constructor needs to have these parameters, then I will simply specify them, right? So this is a parameterized constructor. And finally, I need to have a constructor which allows me to create a copy of a given object. Okay? So that is a copy constructor. So the copy constructor, of course, this has to be float. This was float. Copy constructor is a special type of a constructor whose argument will be a reference type. Okay. What is this? A reference type. Now, if you recollect, we have what is a pointer. This is a copy constructor. Okay, let me just. We have whenever we have variables in C++. The three different types are the simple normal variables that we have. We have the pointer variables, and the third type of variable is a reference variable. Okay. Now, since this copy constructor makes use of a reference variable, before we actually study this, how it works, we need to understand how a normal function works when you pass a reference parameter to it, when you pass a parameter by reference to it. Okay, so let me just go to that first, because see, this is a function anyways. This is a function, right? Rectangle. This is also a function only, but only it's a special function. So before we actually see how this will work, we should know how parameter passing by reference works. Okay. So for that, let me take simple example. Remember the swap function. What is the swap function? Usually there are two types we have seen in C. One is, suppose you want to swap these two numbers, you have int, or you can have, what is the other type? Other way that you write is int star, right? This is passed by, what is the first variant? Passed by, what is the
Value.
first value? The second variant is passed by address
Address.
or pointer. Okay, and the in C++ there is there. Okay. In C++ there is a third type that is passed by reference. So how will it look like? Right? So now if I'm writing this function and I want to call this function from main, then what do? I have my normal variables x, and I want to call this function. So I'll just comment these two functions for now. I'll define only this function. Let us name these as these formal parameters a and b. Okay. The body of your swap function will remain same. What will you write here? Now the question is, what will you write here, right? We know the code t is equal to a is equal to b is equal to t, right? But you know this is a reference parameter, so what should we write here? Okay. When you are actually passing by reference, how will you pass the parameters? That is a question. So for that, you should know the concept of a reference. So I just want you to just recollect what you learned about reference variables. When I declare a reference variable, how do I initialize it? If a is my reference variable, this is my reference variable, right? How do I initialize it? Some other variable or two, right? I need to have a variable, and then I say in address of a is equal to b, right? Yes or no?
Yes.
So what is happening actually? B is your variable which is there. Suppose this is your variable. B is your variable. Let me call it x1. X is your variable. It is having the value 5. When I write this statement, what happens?
The same location is given the name A as well.
Very good. So the same location can be referred to by the name A as well. So you can say A is a nickname. Okay. Or A is an alias for X. A is another name. You can use either A or X, you will get the same output. So if I say C out A, or if I say C out X, I'm going to get the same output. That is, what should I get?
5.
5. Right? So that is the concept of a reference variable. Now what you're doing is you're going to use this mechanism in a function. You're going to use this concept in a function. So what you're doing is you're writing int address of A, int address of B. So if I want to say A is equal to, so when I'm calling this function, how will I call it? You tell me. It will be x comma y, right?
Yes, ma'am.
Because the way you assign a reference variable a value is directly on the right hand side. You'll have the variable name to which you're going to assign it to. Yes or no? So the assignment is something like address of a int a address a equal to x, address b equal to y. So what is happening? Instead of x, I'm using the name a. That is what I'm doing. Okay. So what happens here is I will say t is equal to a is equal to b, and b is equal to p. So if I do a cout for x and y, before swap and after swap, then I will see what the output is. Okay. Let me print each of these on the new line. So what has happened? It has swapped. Okay. So in this mechanism, you're not using any pointer as such. No concept of a pointer. You're using the concept of a reference to your advantage. So what is happening is, instead of this 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 x, what you're doing, x only, this x is a, so it's a, this a actually is actually nothing but x, so it's pointing to the, it's the same memory actually. It's not in swap's memory, it is in main's memory. It is referring to that variable, right? A is referring to variable x. So what is happening? Ultimately, you're getting
Yes.
that address inside swap, and that is how you are able to change it. Very simple, in a very simple fashion. Only thing is, you will need to create that as reference parameters. That's it. Nothing else changes. It is, isn't it similar to your pass by value? Only thing is that you're using reference parameter. Everything else, the body of the function is same as pass by value. Yes, one. Right? If I remove this reference, it will give me 5, 7 only as out. If I make this a normal parameter, int a comma int b, then this will give me 5, 7. Only thing is, I put a reference parameter and magic happens, right? It's not magic. Actually, the reason is it is just an alias for that memory. Fine. So this is the concept of pass by reference. So which you will be requiring for the copy construct. That is why I had to talk about. Anyways, let us switch back to this rectangle class. Okay. So now what we have done is, these are the possible constructors that we can create. And since these are the possible constructors that we can create, what we do is we will see how to write the definitions one by one. So we have just written the signatures of these functions. These functions are special functions. They are constructors. We have written the signature, the prototype. Now we will write the definition of this. So how will we write the definition of this? You need to write, you're writing it outside. You can write it inside as well. If you write it inside, what happens to this function? If I write the definition of the function inside, what happens inside the class? It becomes
Becomes an inline
Inline
function.
function.
it becomes an inline function. So let us not make it inline, right? Let us write it outside. Now, one more thing is, let me change the way I wrote the program last time. Let me write it below main. Can I write it below main? I can write it below main. Why? Because this is the signature. The signature of the function is already defined in the class. So I can write it anywhere. I can write it above main. I can write it below. I can write it anywhere. Typically, you write the function. If you go back to C programming, if you compare this with C programming, you write the function prototype before main. You write the function definition after, right? That is the traditional way that you write. So you can
Yes,
write,
ma'am.
so that you can write, use the same, you have to use the same way here also. That's the correct way actually. I can say it is the conventional way in which it is written. So I write it below me. Okay. So I say rectangle, but I need to use the scope resolution of it, right? Because I'm writing outside the class. So when I write a function, normal function using scope resolution operator, what is the syntax? Return type followed by class name colon colon, that is scope resolution operator, and the function name with the parameter list, right?
Yes,
Yes,
ma'am.
sir. Now what is the thing? I do not have the return type. This constructor does not have a return type. So I will directly write the class name to which it belongs, that is the same name as the function, and then I will write the function name. Okay. So I'll write it in this fashion. The class name colon colon function. That's it, with the parameters. First is not having any parameters. So I will say length is equal to, say, 1, let me give some default length, and breadth is equal to, okay. So by default, my rectangle will have length 1 and breadth 1. Okay, because I could have written 0, but it does not make sense, huh? To have the length as 0, the length and breadth as 0, right? So I made it as length 1 and breadth 1. Now, similar to this, I will write the others also. So first of all, let me write the simple parameterized constructor. So it is so float L, same way that you're writing a function, the same way, nothing changes. Only remember what is the role of this constructor. What is the role? To initialize an object of the class. What is the job of a constructor? To initialize. That is what we're doing. During creation, whenever you're creating an object, you are initializing that object. Right? That is what a constructor does. Length okay. What about the last one? That is a copy constructor. What about the last one, the copy constructor? Referenced. Let me call it R. What will I do now in the copy constructor? What is the role? What is the job of a copy constructor? This is a pen. I want the pen similar to this pen. I show the shopkeeper this pen. That is copy. I need a copy of this pen, right? Can you remember that example?
Yes, ma'am.
So what should we write here?
R is equal to another rectangle object which was predefined.
Which you are actually passing, right? See, this
Yes.
whatever you are passing is the pen. The pen that I'm showing to the shopkeeper is that object, and the new object will be created by this constructor. This constructor is
Yes.
going to create a new object. What will be the length of that new object? How will you refer to the length of the new object? It is length, right? It is this data member length. See, here also wherever we have written all the constructors so far, what are we doing? We are initializing the data members of this object, of the object of this class. So of this class that you're going to create to whatever parameter you are having. So you are saying length is equal to L, breadth is equal to B, right?
So here length is equal to R dot length.
Very good. Length is equal to R dot length because R is an object, but it is a reference. It's just an alias. Okay, whatever you're going to pass, that object, that is going to refer to that. So it's going to be length is equal to R dot length. Similarly, breadth is equal to B dot breadth. Right?
R dot breadth, no ma'am.
Sorry. R dot breadth. Right. This object's length, whatever you're passing, this object's length, give me a new rectangle, which is the same as this object's R's length, and which is the same as R's breadth. Are you getting it now? Everyone, except for Shrutiman, no one is interacting. You're getting it or no?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. So these are the constructors. Now we'll see how to call these constructors. Any doubt so far? Any doubt?
Yes, ma'am. Can we pass more than one argument into the copy constructor?
So this is the definition of the copy constructor. You are creating an object of this type. See, understand the purpose and then do it. Okay. Later on, when we do the discussion, I am going to talk about what give you the summary of all the types of constructors which are possible, the do's, don'ts, everything. Okay, I'll come back to that question. Don't worry. Okay. Now, when you have done this so far, what you do is you can create an object. Now, when I say rectangle R, okay, let me give R1, rectangle R. So, which constructor will be called?
The
Now,
default construct.
the default constructor is okay. Now, whenever there is this, whenever you define your own no argument constructor, the default constructor of the compiler is not called. Okay.
The one which
Whatever
has the
you have
argument
written,
is true.
whatever you have written will get preference. If you have not written, then the compiler does not have an option, right? It has to do that job. But if you give this constructor, then your constructor will be called. Okay. Now, one more thing you should note here, what I have done is I have written 3 different functions. These are functions only, right? I believe that this is a function, constructor is a function. 3
Yes.
different functions, and all these functions having the same name. Yes or no? Only difference is in
Yes.
the terms of parameters. Okay. So this is an example of function overload. You remember that term, function overloading?
Yes, ma'am.
Yeah. So in fact, it's called constructor overloading because it's not only it's not a simple function; it's a constructor. Okay. So that is what is there. We'll come back to this concept again later. But for now, just for this simple example. So this is going to call no argument constructor. Okay. So if I want to print, let me create a print function. Other functions will be there. I have not written the functions. The area, perimeter, all these functions will be there. Whatever is related to this rectangle, you will have to complete the class. Okay. So see out. I'll say length. So if I say what should I get now? How will I call this function? How will I call to print rectangle this function? R1
R1 dot
dot, right?
print.
It's a function of the class. R1 dot print rectangle. Don't forget this ever dot operator. Okay. Now, if I create something else with parameters, okay. So if I pass the parameters, now let me actually first run this and show what this is giving. So it's giving the default length, right? Length and breadth, which I have mentioned in my constructor, right?
Yes.
What if I don't do this? I don't have this. Okay. So the thing is, let me also remove all the constructors. There's a reason for this. We have to remove this also. This is my old output. See what has happened. I did not have any constructor. Okay. So what was called? This was called the default constructor, which is provided by the compiler was called. What does that do? It's giving me garbage values for length and breadth, right? Some garbage values. So default constructor, which is called by the compiler, is of no use for initialization. It's going to the values only. It's going to allocate memory. That is what it does. So for example, when you say int a, what does it do? What does your compiler do? Garbage value. Only memory is allocated for a normal variable. Similarly, for an object, also only memory is allocated of that depending on the data members. But the value is a garbage value. Have you seen this in so far the programs that you have created? Have you observed this? I don't know. Sometimes you must have done this mistake. Without initializing, you must have used
In
that
C,
object.
it happens sometimes.
No, but while creating these objects so far, we have created the objects, na? Only thing we did not write
Yes.
constructors. So you should have, if by mistake you directly call the function without using set initial or something like that, then you will get this kind of an error, garbage value, right? So by default it is garbage. So that is why you have to give the value. Okay. Now, once I put this second one, what is happening now? You are giving this object, second object, which you are creating, that is this. I say r2 dot print.
Ma'am, is the
Yes.
syntax correct in line 22? R2 and the parameters.
Yeah, it is wrong. Why do you think it is wrong?
R2 is the object, right? Not the function or the constructor at all. So and that syntax is used for functions only, as I think. That's why.
Yeah. So how to call it? How to call this function? So it's different than you call a normal function. When you call a normal function, what happens? You specify the function name and you specify the parameter list. Yes or no?
Yes.
So whenever you are having this constructor, then the way to call this constructor, if it is parameterized, then in that case what you do is you specify the object name and you specify the parameters in parentheses. So it's slightly different the way you call it. Okay, rectangle is the object type, the type, followed by the object name, and then you specify the parameters. Okay, it's slightly different. So note the difference in syntax. So this is printing, this is calling your second constructor. And now if I have the copy, the third constructor, what do I need to do? How will I call it? Now, according to this terminology, how will I call it? I have a new rectangle R3, which I want to create. Right?
Rectangle R3 and in the parenthesis R1.
Very good. Okay. So if I say R3 dot print rectangle, So I'm getting the third rectangle as 1, 1, right? R3, I'm getting the length and breadth as 1, 1, which is the same as R1. Okay, if I write R2 here, then what will happen? I will get R2. So I'm making a copy of R2 inside R3. Okay. So please note the way in which this differs from calling a normal function. Okay. You have the class name, you instantiate your object as usual, but when you're calling the constructor, so you just have to pass the parameters. The way you pass the parameters to a function, only thing is the function name is not there. Okay, instead of so close to the object name, you put the parameters. So this is how it is different. So you will find it little different here, but once you get adjusted to this syntax, you'll be doing it correct. Okay, just the object name followed by the parameters. That parameter list will match the constructor. Okay. Now I can have default arguments also inside the constructor. So if default arguments, now what do I understand by default arguments? In functions, we can use default. In C++, you can have default values inside function parameters. So if I don't, for example, if I don't specify that parameter while calling the function, then that default value will be used. Okay. So if I for example in this function, this particular constructor, I say L is equal to 1 and B is equal to 1. Have you written a function with default parameters? Have you tried writing that?
No, ma'am.
Okay. So if you write a function, let me give you one example here with you. Whenever you write a function, so for example, if you're writing a function, okay, in C++, you can have what is known as default arguments to the function. So if I say int a is equal to 1 and int b is equal to 1, and this function is simply going to return a plus b. From main, I can call this function like this. I can call it, I can say, okay, let me write it here. I can say cout, add 3,5. I can also have a call like this. And I can also have a call like this. So what is happening? What will be the value of the first? What will be the output of the first? 8. Right? The output of the second?
4.
So what is happening
8.
is the first 4. It will be 4. First parameter, second parameter you have not passed. Okay. So in that case, first parameter you have passed. So this A will be 3, but the default value of B will be taken. The second parameter will be initialized to the default value. And for the third function, what will happen? Both these default values will be taken. So the answer will be 2. Okay. So you can write this kind of a function. You can explore more on this. You can just try different types of functions with default parameters. But this concept, in fact, is used here for a constructor with default parameters. So what we are doing is we are writing a constructor where we are providing the default values. So B is L is equal to 1, B is equal to 1. So if I create an object now, okay, if I create an object, what will happen? R1.
It will call the second constructor with the default values of the parameters.